one, we can see about in detail about the cryptographic computation. What actually a cryptographic computation? In general, if you're going to see about that, two further items which are going to be get interested over here. The first one is nothing but the creation of a shared master secret by means of the key exchange. And the second one, the generation of cryptographic parameter from the master secret. That is going to be the thing. First, we will see about master secret creation. The shared master secret is it's a one time 48 byte value, which is going to be taken, converted into bits. It's going to be 384 bits will be there, which have been generated for this session by means of secure key exchange. The creation is in two stages. First one, a pre-master secret is exchanged. Second, the master secret is going to be calculated by both parties. For pre-master secret exchange, there are two possibilities. One, RSA, a 48 byte pre-master secret is generated by the client, which is going to be encrypted with the server's public RSA key and sent to the server. So here the server decrypts the ciphertext using its private key to recover the pre-master secret. Second method, Diffie-Hellman. Both client and server generates a Diffie-Hellman public key. After these are exchanged, each side performs the Diffie-Hellman calculation to create the shared pre-master key. Both sides now compute the master secret key, and where the client hello random and server hello random are the two nouns values which have been exchanged in the initial hello message. And let me see about how the generation of cryptographic parameters are going to be made over here. Here the cipher specific requires a client write max secret and a server write max secret, a client write key and a server write key, a client write IV value and a server write IV value, initialization vector value, which are generated from the master secret in that order. So these parameters are generated from the master secret by hashing the master secret into a sequence of secure bytes of a sufficient length for all the needed parameters. Such a way, the generation of the key materials from the master secret uses the same for the generation of the master secret from the pre-master secret. Okay, until enough output has been generated, which is going to be get created. Then the results of this algorithmic structure is a pseudo-random function. So we can write the master secret as a pseudo-random seed value to the function. The client and server random numbers can be viewed as a salt value to complicate the cryptanalyst. Okay, so that is the way it's going to be get generating the cryptographic computations. So next we are going to see about HTTPS. So what actually an HTTP is? HTTPS is nothing but hypertext protocol. We are going to see about this, which is going to be an HTTP over SSL, that is going to be called as HTTPS, which refers to a combination of HTTP and SSL to implement a secure communication between a web browser and a web server. So here the HTTP's capabilities is built into all modern web browsers. It depends on the web server supporting an HTTPS communication. For example, some search engines do not support HTTPS. Google provides HTTPS as an option. HTTPS, for example, the URL may be taken as https google.com or https colon double backslash URL rather than HTTP. That such kind of things are going to get present over there. So the principal difference seen by an user of a web browser is that an URL, uniform resource locator, that is going to be called as a URL, which addresses begins with HTTP rather than HTTPS. A normal HTTP connection uses a port 80 whereas if HTTPS is specified, which is going to use the port 443 rather than 80, which is going to get used over there, which is invokes SSL. So that what happens when HTTPS is used, the element of the communications are encrypted by an URL of the request document, content of the document, content of the browser forms, cookies which have been produced or cookies which have been sent from the browser to the server or from server to browser, as well as the content of the HTTP headers. These are the things which are going to be communications are going to get encrypted over there. So HTTPS is documented in record format 2818, which have been HTTP over TLS. There is no fundamental change in the in using the HTTP over either SSL or TLS, and both implementations are going to be referred as HTTPS. Let's see about the connection initiation and the connection closure, which is the uses of HTTPS. For HTTPS, the agent acting as the HTTP client also act as TLS client. So here the client initiates a connection to the server on the appropriate port and then sends the TLS client hello to begin the TSL handshake. When the TSL handshake has finished, the client may then initiate the first HTTP request. All the HTTP request data is to be sent as an TSL application data. Normally, an HTTP behavior, including retained connections, should be there are three levels of awareness of a connection in HTTPS. At the HTTP level, an HTTP client requests a connection to an HTTP server by sending a connection request to the next lower layer. Typically, the next lower layer is nothing but TCP, but it also may be a TLS or SSL. At this level of TLS, a session is going to be established between a TLS client and a TLS server. So this session can support one or more connections at any time. As we have seen that a TLS request to establish a connection begins with the establishment of a TCP connection between the TCP entity on the client side and the TCP entity on the server side. Such a way the connection initiation is going to be happening in the HTTPS. Then connection closure. How the connection closures are going to be happen over there? An HTTP client or a server can indicate the closing of connection by including the line which is going to be called as close connection or connection close in HTTP record. This indicates that the connection will be closed after this record is going to be delivered. So the closure of an HTTP connection requires that the TLS close the connection with the peer TLS entity on the remote side. So which will involve closing the underlying TCP connection. At the TLS level, the proper way to close a connection is for each side to use the TLS alert protocol to send a close notify alert, so that the TLS implementation must initiate an exchange of closure alert before closing a connection. So that what happens, a TLS implementation may, after sending a closure alert, close the connection without waiting for the peer to send its closure alert. So generating an incomplete close, so that an implementation that this may choose to reuse the session. So this should only be done when the application knows that it has received all the message data that is going to be that it cares about. So that what happened, the HTTP client also must be able to cope up with a situation in which the underlying TCP connection is going to be terminated without a prior close notify alert and without a connection close indicator. Such a situation would be due to a programming error on the server or a communication error that causes the TCP connection to drop. However, the unannoyed TCP closure could be evidence of some sort of attack, so that the HTTP's client should issue some sort of security warning when such occurs, when such kind of closures are going to be get occurred over there. Such a way which is going to create an connection initiation and connection closure in the HTTPs.